Hello everyone, I'm very happy and excited to join ASCAAD 2022. Representing my research is a privilege for me and I believe this conference will be very beneficial to all of us. The title of my study called that I like to represent today named Using Deep Learning to Generate Front and Backyards in Landscape Architecture. I want to introduce myself. I'm a landscape architect and PhD candidate in Geographical Information Technologies PhD program at ITU. I like to introduce our multidisciplinary research team. That group has been created by landscape architects, an architect, and an engineer. Professor Tuncay is the head of the Landscape Architecture Department at Istanbul Technical University. Dr. Aslı leads the City Development through Design Intelligence Lab at ITU. They are my PhD thesis advisor and co-advisor. They supervised this research. We work together with Dr. As in the GD lab on various topics such as AI, smart and green technologies for future cities. The research purpose is to understand the use of artificial intelligence in design disciplines. Can we use AI as a design tool? Can we develop an AI-aided design software? With this research purpose and questions, we focused on our literature review. Search dealing with the intersection of AI and design disciplines form a cluster that gathers in the architectural design discipline. From these studies, we can understand the design data relationship with AI to use of different dataset, data types, and different artificial neural networks. We realized and identified our research gap. There is no study focused on the field of landscape architecture. Rather than that, review studies in the literature review show us AI and built environment is a very important topic and has the potential will change our design traditions. We aimed to create an AI system to produce a landscape plan with this experimental research. Our dataset is provided from database management system of online repository named arcbazaar.com. Raster is our data type. Generative adversarial networks is our artificial neural network in this study. Our expected result is AI-generated landscape plans from sketches. In this slide, we can see our study workflow. We can divide that 4 stages. First, query from database management system of online repository. Second, data preparations of dataset 1 and 2. Third, training process of Pix2Pix. And last, generating new garden plans from sketch. We can understand that workflow online repository has different types: home, garden, commercial and institutional projects, architectural and urban design projects, and also have landscape projects. We queried all categories and we obtained front and backyard garden plans with V2 score higher than 5. And we have our garden plans, and it will create dataset 1 and then dataset 2. With those 2 datasets, we can start the training process of Pix2Pix. Trained Pix2Pix will generate new garden plans from sketch. We can see our data collecting process and first dataset. We will see our examples, landscape plans, and our micro-scale front and backyard. Result of the queries from database management system, we obtained the link of the determined scope. The obtained links had various types such as perspective, diagrams, sections, and at last the plans we need. One by one, all links are downloaded and discarded if it is not a plan. 224 design examples were ready for machine learning process. It created dataset 1 out of 300,000 images, and we can see our database management system of online design repository, and we obtained front and backyard garden projects, and we need to vote it more than 100% and 100 times. It means in other query, we obtained the projects have voted 5 and more on 10 in beauty score. With these complex queries, we obtained our dataset 1, as you can see in the right of the screen. Dataset 2 is created. The semantic segmentation process is manually completed in CAD environment. As a result of the process, dataset 2 was ready for the training process of the Pix-to-Pix. 224 design examples were ready for machine learning process. It contains second dataset. In this study, we want to work on the supervised machine learning method and to have comprehension of it.
We initially trained the model with 224 images and with ReLU activation function. If the input is positive, the ReLU will output input directly. If it's negative, it will output 0. The images are resized into 512 by 512 pixels in order to be able to use them for training. After resizing the images, we paired them for training. Initial data contained 224 garden images and 224 sketches that were generated based on the garden images. After the first trial, the Pix-to-Pix model was trained again with the MISH activation function. MISH function is a novel self-regularized non-monatomic activation function, and it improves the performance of neural networks. We not only changed the activation function, but also rotated original images in order to increase the dataset. The final model was trained with 672 images. The results were promising. The system was able to construct various landscape designs based on entirely new sketches. The developed model with ReLU activation function is tested with new segmentation inputs, as can be seen in figure 7. And the second model with MISH activation function is tested also with new segmentation inputs, as can be seen in figure 9. The results demonstrated that our model is able to transform simple sketches into landscape plans, and the results of the second model were improved and have high resolution. The model is trained with 212 epochs to improve the output. The training results have shown that MISH activation function and the additional data improved the first model. We can change or develop our dataset to improve the results, and satisfactory results of the study encourage us to work with raster data type in future AI search. After solving the example resolution problem, we will work with the different landscape architecture scopes, the huge master planning scales. We work on supervised, unsupervised, and hybrid ML studies. The research aspirated us to work with our own dataset, style, and approach. Future aim is developing an AI-generated design mechanism with an ecological design approach. Our prediction in the future, AI-aided design mechanism as a design tool will be accessible for working with remote sensing data. Here you can see our references.
Thank you for your attention and interest. I want to mention that the author is supported by YOG 102,000 doctorate scholarship and TÜBİTAK 2232 program.